So side-side angle, where you have two sides and an angle which is not in between them, is not a triangle congruence because suppose you're given this side length, and this angle, which is not in between them. From this diagram, you can kind of tell. So I don't know the length of this base, so I'm going to draw a ray. It's something along here. But based on the fact that this angle is fairly large and this side length is pretty small, there's just no way for this side length to complete the triangle. It might be totally impossible. Given a choice of two sides and an angle not in between them, it's possible that there is no way to finish that off. It's also possible that it's exactly right to join down at a right triangle. If I tried swinging this around, if I swing it this way, I'm not going to hit it. If I swing it this way, I'm not going to hit it. There's exactly one way to complete it as a right triangle. So maybe there's exactly one answer. Or maybe if you take this side length and start swinging it around, there's two possible ways to complete it as a triangle. Okay, if it's so ridiculously long that trying to swing it around will miss completely and come back around here, then you're back in the land of one triangle. That could solve it. So angle side angle might be no solutions. It might be a right triangle unique solution. It might be two solutions, and it might be one solution that isn't a right triangle. So there's a lot of ambiguity here. So how on earth are we going to determine what's what? Well, you're going to use the law of sines. You're just going to be careful about possible quadrant ambiguities. So let's see. We've got two sides, A and C, and one angle which is not in between them, because the angle in between A and C would have been B. So I like to start by drawing a triangle that makes no effort at being accurate. I'm going to call this my unknown angle B. This is my unknown angle, A. This is my unknown angle B. This is my known angle of 50 degrees. Across from 50 degrees goes a side length of 1, and across from angle A goes a side length of 2. So then I have an unknown length 2. Across from angle B goes the unknown length of B. So I do have the sides A and C. So let's use the law of sines version that has A and C in it, because then these two are known and this angle was known. So there's only one unknown here. Okay, so the sine of A must be 2 times the sine of 50 over 1. Now, the sine of 50 degrees is about 0.75 something, which means that 2 times it is bigger than 1. How can the sine of A be bigger than 1? It can't. Okay? You cannot have the sine of A being bigger than 1, which tells you this is simply impossible. Okay? There is no solution here. And you know what? Sometimes final exam problems gives you a triangle with no solution. You would just write, because we have ended up at a position where we need the sine of an angle to be bigger than 1, that's impossible, there's no solution. If you didn't have a calculator, by the way, how would you solve this? Okay, so if you don't have a calculator, let me clear off pen marks. You're at this point right here. Sine of 50 degrees, okay. Here's the unit circle, right? I know at 45 degrees, the sine of 45 degrees is root 2 over 2. As I rotate, I am actually a little bit past that. So the sine of 50 degrees is bigger than the sine of 45 degrees because my height went up a little bit. The cosine would actually be smaller. Okay, it's moving to the left, but the sine is still moving up. So the sine of 50 is bigger than the sine of 45. That's root 2 over 2. Then I would end up solving for the sine of A has to be bigger than the square root of 2, which is definitely bigger than 1. So even without a calculator, just by observing 50 degrees is a little bit past 45 degrees. Specifically, the sine, the y-coordinate, is still going up. So the sine of 50 degrees is bigger than root 2 over 2. We can still get that problem that we have a sine of an angle being bigger than 1. Calculators are never required in this class. Okay, so anyway, no solution for this one. Here's another example. We are given two side lengths and an angle, and the angle is not in between them. So I like to draw a picture, which hopefully is not going to meet their text. Yes, it will. So Oh, they draw a picture this time. Great. So we have the angle A, 60 degrees, across from it, side length A, which was 4. If this is going to be the side length B, across from it, I put the angle B. And then my side and angle C are just the missing ones. So what do we have? We have side A and B. So use the law of sines that mixes A's and B's together, this one. Okay, because you have the most known quantities. You know this side, and you know the angle A. Well, thankfully, sine of 60 degrees is something we actually know exactly. Okay. The sine of 60 degrees is root 3 over 2. So this is approximately 0.65. It's exactly 3 times the square root of 3 over 8. Okay. So I have the sine of B is about 0.65. But there are 2 angles that do that. So here's the unit circle picture. Okay. Here is a sine of about 0.6 something. There's a quadrant 1 solution, but there's also a quadrant 2 solution. If I use the law of sines, we're going to get, if all you did was this, the arcsine of 0.65. That doesn't give me 2 solutions. It gives me the quadrant 1 solution. So now, that means by symmetry, this angle is the same, which makes this angle pi minus the arcsine of 0.65. Assuming we're working in radians, if we're in degrees, it would be 180 degrees. Okay. So arcsine only gives you angles in quadrant 1 or 4. If you're also looking for something in quadrant 2, you're going to have to do one of these symmetry arguments to figure out what it is. So the arcsine of 0.65 in degrees would have told you 40.5 degrees, which means the other one is 180 degrees minus it. So here are 2 possible solutions. Okay. However, in this example, remember one of our angles was already 60. So we have an angle of, say, 60 degrees, and now we found an angle of 139 degrees. Hey, now I have 2 angles. I immediately find the last angle. But in this case, this angle would have to be negative. That doesn't make any sense. So even though the arcsine function had some ambiguity to it, in this example, it turns out that one of the solutions was extraneous. It wasn't really going to be legitimate, okay, because it would end up with too much angle in a triangle. In the picture, this corresponds to where this side is so long that if you swing it around, it misses this direction completely. So in theory, it could come back and intersect, but this would require going in the other direction. So it's an extraneous solution. So 40.5 degrees is the only legit choice for that angle. Now I have 2 angles. I can find the third angle at 79.5. Now that I have all the angles, we can use the law of sines directly to find the missing side length. So now we have solved that. So we've seen an example of one solution given 2 sides and an angle. The previous example, of course, had no solutions. So what do you think the next one's going to be? What if there's 2 solutions? So we're given 2 sides and 1 angle. The angle is not in between those 2 sides. So we're in the Ssa scenario. And you can always recognize this by just drawing it. Okay, if I call this angle 40 degrees, that's A. That means across from it goes side length A, which is 7. If I call this 9, that's little b, which means this is capital B, which means that's capital C, that's little c. I have side, side, angle. So we're going to use the law of sines to try to find some angles in here. Okay. So because we're given side lengths A and B, we're going to use the law of sines equality that involves A and B. Utilize what you are given to find something. So that is going to eventually yield, okay, that the sine of B is 9 times the sine of 40 degrees over 7, or B is the arcsine. Sorry, that shouldn't say arcsine of B, that's just sine of B. So that's about 0.83, but that's going to be our quadrant 1 solution. So the quadrant 2 solution is exactly going to be, whoops. So if I take the arcsine of 0.83, we get 55.7 degrees. That's our quadrant 1 solution. So our quadrant 2 solution is 180 degrees minus that. If you're working in radians, like if your calculator's in radians because you're a reasonable person, then your arcsine of 0.83 would be something else, and then B2 would just be pi minus that. Fine. But I have two solutions here. Okay. Now observe, if I combine with our known angle, either one of these is actually okay, because adding them up is not going to exceed 180 degrees, which means there are two possible solutions. Okay. Both choices are fine. We haven't exceeded 180 degrees, so we're in the picture below. There's actually going to be two possible choices. One of them, okay, corresponds to having picked something pretty small. The other corresponds to having picked something fairly large. Actually, it's these two choices here. Okay, this one is going to be our 55-degree angle, and this is going to be the 124. So there's two possible choices for the third angle. Okay, if I had chosen B to be 55.7, then the remaining angle would be 84.3. But if I had chosen B to be 124.3, the remaining angle would be 15.7. That's fine. Okay, there are two possible solutions, which means finding the extra side, because remember, we were given two sides, 9 and 7. To find the extra side is going to have two possible solutions. So we're setting up the law of sines to find the missing side C. But we know there's going to be two possible solutions, one corresponding to having that third angle be 84.3 degrees and one corresponding to have it be 15.7 degrees, which means we get two different side lengths, okay, which means there are just two possible solutions. So the way this is presented on like the final exam is there's like a table. It just says like complete the following. And I need 6 rows, 1, 2, 3, 4, 5, 6. And it'll just say like A, B, C, A, B, C, and some of them will be filled in for you. So you might, for example, be given two sides, let's call it 10 and 6, and one angle, not in between them, so 100 degrees. Sure, why not? So at this point, you would just fill this in. If there were two solutions, you could just like draw an extra row on here and say solution 1 and solution 2 and fill them all in. Okay, so sometimes if there's two solutions, you're going to have to add on to our little table. If there aren't two solutions, if there's only one solution, just fill in the missing bits in the table. Whoops, let me clear out my nonsense. So yeah, so they're showing both of these in one diagram. Depending on whether you had chosen this or this as angle B, okay, the smaller choice of angle B gives the larger choice of angle C. The larger choice of angle C gives the smaller choice of angle C. And then I get two different possibilities for the side length, either just this or all the way out here. But there are two possible ways to complete this triangle. Okay, so that's where we'll stop here. When we come back, we're just going to continue working through this and do sort of more word problem type stuff. But it's all going to be completing the triangle to find missing information.